our next speaker, Asma from INRIA, will be also talking about server-side tracking on Meta.
Nice. I'll start? Yes. So hello, everyone. Thank you for being here. My name is Esma, and I'm honored to present to you guys today our work on measuring the effectiveness and accuracy of the client-side and server-side tracking tools on Meta. So this work focuses on two technologies provided by Meta. That is the Metapixel and the Conversions API. So the Metapixel is your average third-party trackers. It means that it relies on third-party cookies. So let's say I have a website and I've implemented the Metapixel. When an internet user accesses my website, a tracking script is loaded onto their browser. From there, the tracking script will collect third-party cookies installed by Facebook. It will collect the interaction data of this user, that this user is having with my website, and it will take everything and communicate this directly from the browser to Meta. Now here, Meta will use the third-party cookie to link the website visitor to a social media profile that I, as the website owner, can target with advertising campaigns on their social media. Okay, so with the deprecation of the third-party cookie, we see an emergence of a new tracking technology, which is the Conversions API. Now, with the Conversions API, the tracking script and logic has shifted to the servers. So now, when an internet visitor or an internet user accesses my website and interacts with it, the interaction data is communicated from the browser to my own servers. And from there, I'm going to communicate this with Meta. However, here, I cannot use third-party cookies that Facebook installs on the browser. So instead, I'm going to communicate with Meta other identifiers. So maybe I will give them email addresses of these website visitors or their phone numbers. And if I don't have any of this, I can just provide Meta with the IP address, the user agent, or maybe the IP-based geolocation data. Now here, we can see that the communications that I'm having with Meta are suddenly hidden from the browser. This makes your job as researchers and regulators much harder. And additionally, you wouldn't know who are the third parties I'm communicating with from the servers. And you wouldn't know what types of data I'm communicating to these third parties. So our approach to this server-side tracking problem, quote unquote, was more out of curiosity to know how effective and how accurate is the use of IP addresses and user agent as a remarketing identifier. So what we did is we put on our advertisers' hats on and we acted as website owners that are attempting to track their website visitors. They are sending this data to Meta, and then we will purchase advertising placements on Meta and attempt to target these website visitors on their social media profiles. Okay? So we do this by first creating websites where we integrate the Conversions API and the Pixel. From there, we would send participants from crowdsourcing platforms like Prolific to these websites. We would collect their tracking data, and we will send it to Meta. On Meta, we will be able to match this tracking data to social media profiles, and we can target these social media profiles with advertising campaigns. We can use the results of the advertising campaigns, i.e. the users who are seeing our ads, as proxies to measure the effectiveness and the accuracy of the Conversions API. So we had a set of experiments, and we wanted to test three things mainly. First of all, the effectiveness. That means that we wanted to know the number of social media profiles we will be able to target with the Conversions API data, which includes, again, IP addresses, user agents, and IP-based geolocation data. The second thing that we want to see is how robust is this technology when it's facing ad blockers or VPNs, things that we know traditionally block the pixel. And then the third thing that we want to see is the accuracy. If I'm only using IP addresses and user agents, how is the matching going to be accurate? Now, we had a lot of interesting results, so I tried to pick out just the key takeaways that we had. So first of all, we set up a measurement of the baseline tracking effectiveness of the Conversions API. What we did is that we put to test the Conversions API with the pixel. So we set up the most ideal conditions for the pixel. We had no ad blockers allowed, no VPNs, no private search extensions, and a browser that allows or supports third-party cookies. So we are fairly comparing the Conversions API and the pixel. And again, the Conversions API, we're only sending IP addresses and user agents. What we see is that the Conversions API was able to reach the same tracking effectiveness as the pixel, which uses third-party cookies, and we were able to reproduce these results multiple times. For robustness, we first tested IP spoofing. We specifically tested VPN-linked IP addresses. The effectiveness dropped to 27%, but for us it was still a weird result or a peculiar result. You would expect that a VPN-linked IP address is being used by hundreds, if not thousands of users online. So really, it shouldn't be linked to a unique social media profile. So this tells us, okay, maybe the Conversions API isn't really that accurate in matching website visitors. The second thing we tested was user agent spoofing. What we see here is similar effectiveness as the baseline results. Okay, so this means that the IP addresses are probably the main identifier that is being used to re-identify our website visitors and link them to their social media profiles. Now, the third is filter list. We tested ad blockers, private search extensions, and browsers like Brave and DuckDuckGo, which has in-browser filter list. What we see is that our calls to the servers that implement the Conversions API were not blocked whatsoever. This makes sense, of course. Now for the accuracy. I need to take a step back and revisit how we measured the effectiveness. So what we had was participants recruited from crowdsourcing platforms. We had these participants go to our website, we tracked them, sent their data to Meta, and then we created these advertising campaigns that target the social media profiles of the users who supposedly generated this data. In the measurements that we had, we only see aggregated statistics. That means that I cannot know the profiles, who are the profiles that are seeing my ads. So to know what is the accuracy of the Conversions API, you need to know who are the users who are seeing your ads to verify that they're the same users who accessed your website. Now, for us, it was really important to keep the participants' anonymity. So we opted for something else. What we did was, instead of using crowdsourcing platforms, we had these advertising campaigns on Facebook to recruit the participants. From there, Meta will give us the users who've seen this recruitment ad campaign. So let's set this aside. Now, when users see our ad, click on it, they will be redirected to a website where we integrated the Conversions API and the pixel. We would collect their data, send it to Meta, create our advertising campaigns that attempt to target these users. Now here, we will be able to compare the users that we were targeting with our advertising campaigns to the users who originally saw our recruitment ad. And we are able to do this through a measurement that we call the overlap. In fact, Meta will allow you to see the number of unique users who saw this measurement ad campaign and who also saw the original recruitment ad. And that's our measurement of accuracy. If your tracker is good, then the overlap should be 100%. For the results, we had a lot of users who thankfully consented and took part in our study. All of our users were on the Facebook in-app browser. This is important to note because it supports third-party cookies. And what we see is that we had 100% of accuracy for the pixel. That means that 100% of the users we were retargeting with MetaPixel data were originally website visitors. However, for the Conversions API, that only applied for 60%. So what does this say? Well, as an advertiser, I just wasted more than a third of my advertising budget on users who have never interacted with my website. And as researchers, this is telling us something that we've known all along, which is while the web is moving on towards the deprecation of third-party cookies, we see an emergence of new advertising identifiers, and it seems that the IP address is quite the decent one. So other interesting findings from the paper, I encourage you guys to see it. We have a lot of interesting results. We also found that Meta's first-party cookies, the FBC and the FBP, have minimal role in re-identifying users for remarketing purposes. We also find that the Meta Pixel can still track users on browsers that do not support third-party cookies. So it won't crash and burn when Chrome decides to block the third-party cookie. Thank you, everyone, for your attention. I hope you enjoyed the presentation. Let me know what you think.
Yeah, we have time for a few questions.
Could you comment, really interesting results, could you comment on what you believe the GDPR implications are of each of these technologies?
So, from my understanding, the GDPR uses the word cookies quite liberally. That means that it assumes that the Conversions API or trackers like Google's server-side tracking are included in the terms of the GDPR. The problem here is that you can't enforce something if you don't know that the website is actually using it. So the regulation is there. The enforcement is the issue here.
Again, great research. Been looking forward to this all week. Have you looked at the markups work? When you put in websites, it does have a banner that says this website will send stuff to Facebook even if you don't consent. And then the second question is, did you only recruit on desktop to test this out? Because it's sort of one of the things that's kind of known in some advertiser communities is that like doing the audience network, you're guaranteed to just get bots. So did you only recruit on desktop?
So. Actually, we had for the effectiveness experiment, we actually deconstructed the experiment into two parts, one for the desktop and one for the mobile, because we did not want to have this interference with our conclusions. For the desktop, we had this accuracy for the Conversions API. On mobile devices, it was the same for the effectiveness. For the accuracy, it was on mobile devices, on the Facebook in-app browser. And for the first question, what did you mean by the consent?
So there's a researcher group in the United States, the Markup, and they've got a tool called Blacklight, and you can drop websites in there, and it will tell you all of the trackers that are on there. And one of the things that it detects, and I don't know how, that's why I wanted to mention it, that it says, you know, this website will send stuff to Facebook or Meta even if you opt out. So they've got some way, I think, of detecting this, and I'm not sure how, but I recommend looking at it as a potential mechanism as you continue your research.
Thank you for this. However, I do believe that the manner in which I implemented the Conversions API, there's no way someone will realize that I'm implementing it. Because, yeah.
Yeah, no, I definitely thought that as well. I checked it on my own website, though. So, because I know I put it on there, and it's showing up on the markup.
Okay,
so
okay,
something's
nice.
there.
Nice.
Thanks so much. Great work. My question is, so this passive fingerprinting, let's say, tracking visitors using IP address and user agent, which is scary because like I have no control on it. But recently, browsers try to redact the information in the user agent string. Do you think this will have an effect, or this was before or after your study?
Okay, so. For the IP address, you have some mechanisms that are already implemented in some browsers. For example, on Safari, you have these relay addresses. The weird thing is that we tested this, we still had effectiveness. Now, it's a question of accuracy. So the accuracy is probably lower, but it works, even with relay addresses, with VPN addresses, with whatever. And for the other question that you had, which was...
User agent reduction, do you think it will have any effect on the effectiveness? User agent strings are sort of, sanitized.
So user agents, I do think that they have lower effect on the Conversions API. In our experiments, here, we had like the similar effectiveness, even though we were spoofing the user agent. We had like these really random strings for the user agent. So there was no reason for this effectiveness. So the IP is enough, yeah.
I just have a follow-up on this, which is, I think, right here.
Oh, sorry.
I think some of the results might be more optimistic than I think what they actually should be, because you need to do a more controlled experiment where, for example, when you're testing whether or not IP spoofing makes sense, you need to get rid of other stuff. For example, the FBP cookie, you need to also get rid of that.
We got
Because
rid
my
of it.
suspicion is FBP cookie is actually
Yes.
playing a bigger role in making
Yes.
sure that the matching is still happening.
So I actually like this comment because we actually got rid of the FBP in this experiment. We, in our experiments in the beginning, we actually did 2 experiments, one with the FBP and one without the FBP. And when we noticed the FBP is playing these things of linking event data, we omitted it from our experiments. So we actually used VPN-linked IP addresses with user agents, and we did not use the FBP.
Okay?
Yeah. That's it?
Yeah, let's give our speaker another round of applause.